Okay, gentlemen, I'm going to try and take you through lesson 1.5. And the learning goal for this is that you can solve linear systems using any of three methods: graphing, substitution, or elimination. We're going to look at these word problems and see which method is preferred. Now, most of these are going to lend themselves well to substitution and elimination. Graphing is something we did more in grade 9. And when we're given specific equations, it's easier to graph. But in these scenarios, we're going to see that it's better to use substitution or elimination. So let's get started. The first question asks us about a boys hockey team holding a fundraising car wash. They charged $5 a car, $8 a van, and they washed 44 cars and vans. So 44 vehicles in total. We don't know how many of each, but there's 44 vehicles, a mixture of cars and vans. And they collected $262. Based on that information, we're going to come up with two equations and then determine how many of each type of vehicle they washed. So I went ahead and did the let statements for us, but I want to point something out to you here. When it asks how many of each type of vehicle, the how many part is really important because that's going to frame your let statement. So therefore, my let statement, I wrote let C represent the number because we're talking about an amount. Okay, so when it says how many of each type of vehicle, then our let statement will be then worded let C represent the number of cars washed. That's important information for communication. Because it's also going to affect how we write our equations. Okay, and then of course with V for vans, let V represent the number of vans washed. So keep that in mind. So now when we're thinking about our first equation, generally the first equation is a simple one. Okay, because we're looking for the number of cars and the number of vans, and we've already been given that there's a total of 44 cars and vans, then we can say C, which is the number of cars washed, plus V, the number of vans washed. In total, there's 44 of them. Okay, and then the second equation is generally all about the content, the money. We have some more information here: the 262, the $5, and the $8, and that's going to let us figure out the second equation. So for the second equation, we have $5 per car plus $8 per van, and they collected a total of $262. So the first equation is based on amount or the number of vehicles. The second equation is all about cash, right? How much money per car, how much money per van, and then how much money total. When you're armed with those two equations, and we look at this, I'm going to be honest with you, the most obvious option would be a substitution question. So we can very easily say C equals 44 minus V, or you can say V equal 44 minus C. Go ahead and choose one of those if you like, and try substitution. I may have mentioned in class a number of times that I'm partial to elimination. I like elimination better than substitution. It's just the way my brain works. But it doesn't matter which method you choose. If you like one of those better, just go ahead and do that. I'm going to show you how to do this with elimination, though, for this video. And so I'm going to look at my numerical coefficient. If I want to eliminate one of the variables, I'm looking at the C values. I've got 1C and 5C. In order to make them both equal, I would have to multiply the first equation by 5. If I want to make the V's the same, I'd have to multiply the first one by 8. So I'm going to stick with the lower number and just multiply it by 5. So my new number one equation will become 5C plus 5V equal, and 5 times 44 is 220. So that's my new number one. I didn't have to rewrite number two. I'm just going to use these two equations the way they are right here. And I'm going to use that to do my elimination. So now I have to look at the numerical coefficients on the C because we made those integers. We have a 5C and a 5C. They're both positive. And so therefore, to eliminate them, I need to use subtraction. So I'm writing my subtraction out there. 5C minus 5C is 0. So I don't have to write anything. 8V minus 5C is 3V. And 262 minus 220 is 42. Divide both sides by 3, and V equals 14. And then regardless of whether you chose substitution or elimination, the next part is the same. We have to solve for the other variable. In this case, we're solving for C, or the number of cars. And the easiest equation to use is the first one, C plus V equal 44. We already know V is 14, so we always start with the equation, then we show that we're subbing in. and then we could skip as many steps as possible. So I know C is going to equal 30. And you may remember, in order to complete a proper word problem, you need to communicate effectively. And one way to remember that is LEST, L-E-S-T. L for the let statement, we got that. E for the equations, we've got those there highlighted in green. S to solve the equations, and we just solved for V and C. And T for therefore. So I went ahead and drafted a bit of a therefore statement to save time in the video. And therefore, they washed 30 cars and 14 vans. That's your complete word problem solved using LEST, let statement equation, solve the equations, therefore statement, and all your communication marks. All right. I'll see you guys in class. Hope that was helpful. And see you soon.